A very good evening to you from Cheenta Statistics Analytics Department, and we are live here with our interesting problem of the day. It's based on joint distributions and as if you have heard Avinav Shukla's lecture on how to prepare for IIT JAM MS. Just to any if you focus on any joint distribution problem, it's a continuous joint distribution problem. It's mostly based on integration, okay, multiple integration. So you will see how this problem beautifully boils down to multiple integration problem and how you can use the ideas of multiple integration problem to solve this. And this is a very interesting problem. So stay and bear with the whole solution. It's really important and interesting. You will see most of it's coming out geometrically. So if you have not solved the problem, please stop the video, solve it, and then come back and see the solution. What's the solution? Okay, so let's get started. The idea, therefore, revolves around this density, bivariate density, and it has a certain corresponding region on which the function is defined. Okay, so let's draw the region on which it is defined. So it's defined as x plus y. So f of x comma y is actually defined as 6 by 7 x, and the region is what? The region is x plus. So let's draw it. So region is x is greater than or equal to 0. That means the upper half of the plane y is greater than or equal to 0. That is in this first quadrant where x plus y is equal to 1. That is this. And x plus y is equal to 2 between this. These are two lines of x plus y is equal to 1 and x plus y is equal to 2. This is x plus y is equal to 2 and this is x plus y is equal to 1. So what we get over here? We get that the region on which the function is defined and this and this is very important. This is always a first step. If you don't draw this, it will be really hard to do the problem. You will see why it will be really hard to do the problem. So this is a place where the whole function is defined, whole bivariate density is defined. The density is 6 by 7x, 6x by 7. So on this, imagine the heights are 6x by 7 corresponding to x comma y. Now we have to find out probability xy, maximum of xy. So this is where the auto statistics idea come. Maximum of x comma y is greater than 1. So what we'll do is the following. So we will convert it into what is really known as 1 minus probability. Okay. 1 minus probability maximum of x comma y less than or equal to 1. Right? Why we change this? Because this intrinsically helps us to solve it in terms of because of the result that the event x less than or equal to x and y less than or equal to y is same as maximum of x comma y less than or equal to x, which is super important to understand. Therefore, we can write this as 1 minus probability x less than or equal to 1 and y less than or equal to 1. So therefore, we are now interested in finding the probability of this region x less than or equal to x and y less than or equal to y. X less than or equal to 1 and y less than or equal to y 1. Okay, and therefore let's see how we can find it out. So observe that the point 1 comma 1 lies over here. Okay, 1 comma 1 lies over here, and let's say probability x is equal to 1 and y less than or equal to 1. Okay, x less than or equal to 1 and y less than or equal to 1. So x less than or equal to 1 is this line, right? And y less than or equal to 1 is this line. You can easily find it out. Okay, because this is what 0 comma 1, this is what 1 comma 0. Okay, and this is 1 comma 1, this is what 2 0 comma 2, because x plus y is equal to 2. So it needs your basic high school coordinate geometry knowledge. So therefore, the region on which the whole function is important is this is the where you need to find out the probability. So we need to find out the probability that x comma y lies in this red region. That we need to find. We need to find the probability that x comma y lies in this red region. That is where we want to find the probability of. So how do you find? So we have a region like this. Let's understand this now geometrically. It's all about the double integration problem. So it's 0 comma 1, it's 1 comma 0, and it's this is x-axis, this is the y-axis, okay, and this is 1 comma 1. And you need to find the integration of a function. So what does it mean? We need to find the probability x comma y belongs to this set A that we need to find now. And it's same as probability x less than equal to, so what, how do we find this? Therefore we see it same as integration over this region A, okay, f of x comma y dx dy, okay. And let's replace f of x comma y. F of x comma y is what? F of x comma y is nothing but 6x by 7 and dx dy. The trickiest part of this problem is to understand and exchange the corresponding, how to do the integration of this region where we have x and y. Dx and dy means you can only take in change in terms of x direction and y direction. So you have to break it up into strips of lines which are either parallel to x axis or y axis. This is the basic problem solving strategy. You have to break it into this because why? Because the change is in direction of x axis and y axis. So you have to strip the whole region up in strips of lines which are parallel to x axis or y axis. Otherwise you cannot solve the problem because the variables over here are x and y. So let's do that. So let's see that there is no x over y over here. So what do we do first? A basic strategy, I think it will be good, is that to eliminate y and transform the entire problem into x. So we have to transform this area of this like the integration of this function over this area into strips of y first and then x. So therefore to change it into strips of y, what we will do is the following. So we will integrate, we will change into, we will break it like into, we will divide it, we'll like divide the whole region into strips like this, red strips. Like they're very, very close, but I'm doing it at a discrete state. But they're very, very close. Like combining all the red strips, we will get the entire region. So let's understand this, how we will do the red strips. So it's dy, okay. So there's 1 over here because everything is dependent upon x. So 6x by 7. We'll see over now dx upper last mein. So what we do is that we first divide it into strips of red, that is the y-axis parallel to y-axis. So therefore understand these are it's 1 because it's not dependent upon y, this function, and dy. So now where does y go from? See, if you fix, let's say x, if you constant fix, keep x as a constant, that's what we do. This y is going from this point. Let's say you fixed x over here. Y is going from, what is this line? This x and x comma 1 minus x, because it's x plus y is equal to 1, this line x plus y is equal to 1. So this point is x comma 1 minus x, and y is therefore going from 1 minus x to 1. So integration of y goes from 1 minus x to 1, okay, and we integrate 1 over that dy, and then x. Now understand, x is varying from this point to this point, right? And then it will combine the entire region. The red strips will be combining and making up the entire region. So x is going from 0 to 1. So what is really happening is that x ka limit is therefore from 0 to 1. Okay, the relationship is in therefore. So understand the strips are becoming size are becoming slow every single step when x is going from 0 to 1. So therefore this strips in this entire region we have to put into strips parallel to y-axis. You could have also done it in parallel to x-axis also. So that's also possible. But we are doing it in terms of y-axis because that's the way it works. Like it will be really helpful over here because it's not dependent upon y. So therefore what we have done, therefore we need to find the integration of this, that it's integration 0 to 1. Okay, it's integration 0 to 1, 6x by 7, integration 1 from 1 minus x to 1 dy, and we do the entire y on dx, like we do the dx part. And what we get over here, it's compute, it's very easy, 0 to 1, 6x by 7, and it is what? It is just 1, it's just x, right? The length is x, 1 minus x, that is x, into x dx. So you get its integration 0 to 1, 6 by 7 bahar le lo, it's 6x square dx. So you get it's x is cubed by 3, 1 by 3, so you get 2 by 7. So 2 by 7 is the form over here. Understand that, therefore, we have found out that 2 by 7 is this, so it's 1 minus 2 by 7, which is equal to 5 by 7. So we have got the answer. So see how beautifully, using the geometry of the entire region and using the ideas of double integration and this change of radius and this is super easy and super beautiful. Geometrically, it's very aesthetic to my eyes. Yes, so you're right, Nikita. I think it comes out to be 6 by 21. That turns out to be 7 by 2 by 7 only. All right, yeah, perfect. Thank you, Nikita. So yeah, so this is a very important problem. It's a very interesting problem. The idea is super important. And drawing diagrams and using your coordinate geometry knowledge, which is really basic to your high school mathematics, so is really helpful for this. So I hope you enjoy the problem, and I will come back tomorrow and soon with a new problem. So stay tuned and stay blessed. And yep. So yeah, also if you're looking for some crash courses for your preparation for IIT Jam next year, so do check our link below in the description, hoping it will help you. So good night, guys, and stay tuned and stay blessed. I will see you in the next video soon. Yeah, by the way, if